Howdy, howdy, howdy. It's been a while, but I'm back. I wanted to get back in touch with you guys. I've been wanting to get back in touch with you guys for a while. I just haven't had the time to make a video. I'm just getting back from a tutoring session, so I'm going to jump in here and make a quick video before I got to go do some more work. So in this video, I'm going to cover our basic setup for beginning in electronics, and I have that here. And we'll go over some of the tools and parts that you'll need to begin in electronics. And then I'll show you what's a more advanced setup, at least for in what I consider an advanced setup, for myself. But before I do that, I actually want to give you a little preview of a project that I've been working on. And we'll do a little bit of an unboxing. I had a box here I've been wanting to open for a couple of days here that has to do with some of the parts that go into this project. So in this project, it's actually more electrical. It's not electronics, but I just figured I'd show you guys just because, like I said, it's not really that interesting, but hey, let's just check it out anyway. So if I don't know if I've mentioned, well, I think I have mentioned in the channel. I don't know if I've mentioned it recently, but I am in the works of starting a STEM program here on our farm. And part of that is an aviation program. And as part of the aviation program, we actually have an FAA approved AATD flight simulator. And that flight simulator needs a power source, as you might imagine. But this flight simulator is actually going to be in a trailer, and I need it to be able to be hooked up to power, so 120 power, and also be able to switch the to 120 to power from a generator as well. So I need both of those modes of operation, and this is what I have this box here for. So like I said, it's nothing really that technical, but it's come along, and I've just been waiting for some parts recently to put it all together. And let's unbox those parts, and then I'll walk through what everything is in here. So this is just a light. This is just so we can have some visibility in here when we need it, if we need to check something or throw a switch, anything like that. But the interesting part of this package lies in these two boxes here. So in these two boxes, I've actually have something in here that I've seen a lot of. I've seen them online, but I never really had any purpose or interest to have one or use one, so I never did. But this was actually a great opportunity to use one. This is something I haven't mentioned too much, and part of that is because, just because of my design philosophy in a sense, and how I try to make things rigorous enough to where you implement your own knowledge and you're learning something, and you're also doing a good bit of the engineering work, which is why I tell you guys all the time, I want you out there, learning on your own and implementing things on your own and making mistakes on your own so you learn, right? But there's all kinds of, in the last, 15 years, there's all kinds of aftermarket circuits that you can buy that are really helpful to electronics hobbyists or electronics beginners that want to build things, and they can build them basically from pre-made prefab circuit boards. Again, I was never that too much into them when I grew up, because I want to learn how to do things myself, but there is a place for it, especially when in the very beginning, just so you can get your feet wet and just soldering and putting things together and wiring things together. And it can give you a glimpse into how circuits, the components that are comprised of circuits, and you can kind of study the circuits a little bit. But like I said, in general, you want to do as much of the work as you can. But the consumer electronics market is not the only thing that exploded. With the consumer electronics market, you also have the prefab market, which, obviously not everyone's a hobbyist, so they don't take that into consideration. But I encourage you to just look up You know, you can go on Amazon and look up some kind of circuit, and you can probably find a circuit for it. You know, you can find a circuit, you know, for a couple dollars, you can find a circuit, especially with like power supply circuitry. You can find stuff like that relatively affordably. And like I said, it might just cut down. It's something for you to learn from, something that you can use in a project, and something that might cut down on the workload for something that you're building if what you're building isn't really that critical. So I bring that up because this is kind of one such object. See, this is a measurement device. So this is going to read the voltage and the current, and I think it has some power readings that it does as well. And I'll have this probably, I don't know, there's one going to be on this side. There's going to be one for the flight simulator, then one for, I guess I'll have one for the air conditioner too. So this whole project here is basically just to be able to facilitate the power that goes to the flight simulator and the power that goes to the air conditioner. And I can flip these cam switches. Oh, these are still open. These are cam switches. Okay, so this is an industrial switch. It's on, off in the center, and then it goes to number 2. So it's on, off, on, basically. So you have 2 different routes that you can put on it. Same thing on both sides. And the reason for that is, again, we have 1 will be the AC, and then 2 will be when you're switching it to a generator power, right? So you have both of the options to do that there, and the center will be off. And then we have our inputs. We just have our inputs on the side here. So that is, I believe, the input for the air condition. Let's see here. This is the input for the flight simulator. And then we have the input for so this is 30 amp input for the generator, which should be plenty. And then we have outputs, I believe one's for the output, one's for the AC, and then one is for like a accessory. Then I'll have my light here while I'll hook up somewhere in the circuit. And we have our main circuit breaker here, which is GFI rated, so which had to be done, not because I wanted to do it necessarily, but it had to be done for the isolation transformer. So in the Tesla coil video, I talked a bit about isolation transformers, and this project will actually have an isolation transformer. So you're actually only seeing the control part of it, right? This is where all the controls are and some of the wiring. But this will actually be fed on this end with this plug here that I showed you here that was going to be for the flight simulator. This plug will actually come from I want to say it's 30. I want to say it's at least 30. It might be 30 or 50 amp isolation transformer, a marine isolation transformer. And I might see if I can find a picture of it, and I'll post one in the video here so you can see it. But what that's going to do is it's going to isolate the flight simulator from everything else in the circuit, particularly the air condition. Okay, because you don't want something that draws that amount of current to be on the same winding. It could cause distortion and noise and stuff like that. So we don't want that in the flight simulator. Also, we just want to protect it from any spikes, because it's an expensive piece of equipment. So we want to protect it as much as we can. So we have an isolation transformer on it, and that's also going to go into our GFI rated circuit breaker here. And I wasn't going to do this initially, but this box, and this is, if you don't know, this is actually a pretty cool box. If you see that these breakers look a little different, they're really made for outdoor appliances. A lot of time they're actually made for like solar appliances. So this is what it has. It has this box that's actually sealed, so no moisture can get in there. It has a really nice locking device here, where you just pinch and open it, and pinch and close. It's pretty sturdy and it's nice. I definitely like it. What it came with a circuit breaker already installed in the box when I bought it, and I believe it's a 30 amp switch. And I figured, well, I'll probably never have another use for it. Might as well use it. So I actually just got to put that on the air conditioning side, and the air conditioner will have a breaker too. But along with that, it'll also have one of these meters, and this meter will again help me keep track of the current that I have coming in and out of this thing. And you know, that's actually a parameter which I'm going to enjoy, because I want to, it's nice, it'll be nice to know how much current I'm drawing, and if I'm ever over current, or if I'm ever, you know, starving a thing for power. The one thing I don't want to do, which it shouldn't be the case, but if, you know, I don't want to put it in a situation, when I say it, I mean the flight simulator, in a situation where it's starving for power or anything like that. It also will keep track of how much power my generator is producing, because my generator doesn't have a display on it. And even if it did, this gives me an opportunity of actually seeing the display while I'm in the simulator, and not, you know, outside messing with the generator. So there's that. Just thought I'd share that. It'll be done soon enough. Just a little project. That's the thing I've been working on the most, that's electronics related. Like I said, you know, most of my work with electronics now is, you know, making videos for you guys, and you know, still doing academic stuff involved in it, but I don't do that much on my own unless I have something to make, and I just don't have that much to make most of the time. But moving forward to our setup, let's talk about what you might need to start in electronics. Again, you know, we've been talking a lot lately about how to start in electronics, and I talked about in the previous video the kind of components you need to be aware of, and along with the tools you might want to. It doesn't have to be that big, but you might want to invest in maybe a small kit of resistors and capacitors. And there's a couple of, you know, there's just a couple of you know, common you know, semiconductors I have in there. But aside from that, you want your materials to work with. So what I have here is some pref board, a multimeter, a breadboard, and some of my tools, okay? And then of course over here we have the soldering iron. So first thing let's talk about is the breadboard. We'll talk about the breadboard because this is typically how electronics is introduced to people. Again, going back to my own background, I wasn't a big breadboard user. I was a pref board user. And I talked about in the previous video. The reason why is, I think, one, because I wanted really hands-on experience doing soldering. So this is just a board with holes in it, and you actually just put your parts in there, and you can cut this. You know, it has lines and all that. The ones I used weren't this big. They were, you know, probably a third of this size, fourth of this size maybe. But you can cut it to your liking and all that, and you just solder on it. You can build your circuits. And the reason why I like to do that is, one, it gave me more soldering experience, but then two, it would produce less noise, because I'll show you over here, a circuit that you build on a breadboard is likely to come out like something like that, where you have a bunch of hanging wires. And if we get into a little bit of circuit theory, or, you know, just kind of electronics, what happens with hanging wires like that? They basically become antennas, right? So they can make a lot of noise. And again, I was dealing with audio electronics, and you don't want, noise is basically your worst enemy in audio electronics. So that's not what you want. So that could potentially induce more noise than what the actual circuit might create if it was, you know, done properly with soldering point to point. So that's the breadboard. Some of them are a little bit smaller than this. This is a kind of a larger one, and it has these lugs. There's really supposed to be feet on here. You can put feet on here, and you can put lugs here to attach a power supply. And in the middle and on the side, so you have a power supply rail, and then you have your places where you would put your object. And what happens is, when you put an object in here, it'll take up that row, okay? So we have these columns and we have these rows. When you put an object in here, it'll take up that row, so that leg of that component will be connected to every other hole in that row. And that's how you make your connections. So if you want to, let's say if you have a resistor and a hole here, then you put another capacitor. If you want to connect them together, you put that in the next hole in front of that in front of that resistor. And that's the basics of your breadboard. Again, you can get something smaller. Maybe try it out, see if it works for you. Like I said, it's not a bad thing. The thing about it is that they're really quick. They use them. You use them for prototyping. And I'll show you in a second how you can get a little bit more advanced with the breadboard. I have a breadboard set up over here that I made a couple years ago to do some testing with some stuff that I usually make. So, aside from the breadboard and the pref board, we have our snips. So we have their wire strippers here. We have our cutters here. We just have some needle nose pliers. And of course, there's various other tools, like screwdrivers and stuff like that. But I'm assuming, everyone's well aware of those things, and they're pretty common. And so are these for the most part. The wire strippers might not be as common, but that's it. And I just really want to show you that you don't what you would use, especially if you're doing anything on the pref board. Actually, you see the breadboard alleviates you from using a lot of this stuff. So because you don't have to really cut any legs or anything like that, you don't have to cut any of the leads on your components. So a lot of this stuff, the needle nose pliers and the cutters in particular would be used to put something in here where you would have to cut the legs off of your component. But you wouldn't do that. So your use of these things would be actually very limited if you used your breadboard, and that might be another advantage. And then you'd have less cleanup and then less waste and all that kind of stuff. And you'd have all your components will be reusable. Now that's one downside to this, is that maybe, I'm not going to say it's not reusable, but you can only solder a component so many times before it gets worn out, and you probably won't want to use it. And if you're doing something where you're testing and you're making a lot of modifications, like if you're going to change something more than I think 3 times, then I think it's better to use a breadboard. But if you have a pretty good idea of what your circuit's going to be, then you solder it up, and if you have to make minor adjustments, you can. So the next one, and I think the biggest item here, the most technical item we have here, is going to be the multimeter. Some people are probably very well aware of them. A multimeter, it really just it tests all your electrical kind of parameters. So this one actually even does capacitors, which sometimes can be unique. Some of them don't do capacitors. This one also can do diodes, which means you can also test transistors, which is nice. Of course, you have the continuity function, which is, I think, how a lot of people know them. This one actually does also frequency, which is very unique. Usually they don't do frequency. I've never really tried it on frequency. This is a pretty good, I think it's like only $30, and it's pretty nice. I can turn it on here for you. I believe it has a nice backlight here. This one even has your tester for AC. Let's see, your AC, if you're testing a house and see if there's power at an outlet, you can do that with this thing as well. But we might get more into depth into that in another video to show the ins and outs of a multimeter. But like I said, I don't know, a lot of people tend to be very familiar with those. So if we need a video on it, let me know, and we'll cover a video on it and test some other things out. So before I go to my setup, I want to show you kind of the more advanced way you might want to set up a breadboard. So now, this breadboard setup is something I made a couple years ago, really to prototype preamplifier circuits. Again, I'm into audio, so it would be preamplifier circuits that I make a lot, or even like guitar effects I make. And I wanted something that was really easy for me to, prototype some stuff. What I have on there is actually a preamp that I was working on that came out really well, and but I just documented it, and now I have it, so I can use that preamp in designs if I ever want to use it. And then on this left side, I have it wired up with a 9-pin a 9-pin socket for a 12AX7 or any other 9-pin vacuum tube. And the reason why I did that is because, again, as you guys might already know, I'm big into vacuum tube circuits and technology and design. And again, I love to make preamps. Um, I've yet to make a preamp or do anything with this, but I might someday. And this actually goes right along with what I made here a couple years ago, which is just like a 250 volt supply. I have a video. I think I have a couple videos on this um, that shows it, but it's like a simple way, basically, that you can make a high voltage source. Okay, for prototyping electronics, and just built a simple box out of it, and it has your plug back there, and I just plug it into the variac over here, and that'll give me anywhere from 0 to 250 volts. So I believe this is actually an isolation transformer that I ran backwards. That had, I think, 2 taps on it. It has 2 taps on it. So basically there's 2 different taps on it. So each of these is about 150 or about 120. And that'll give me, with the capacitance and everything, it'll give me like 250, probably 250 plus there and all that. If you just, if you wire them in series. And there's little LEDs here so you can see when they come on and stuff like that. But so very basic, but very useful. So this would be wired up to this because if we recall, vacuum tubes need high power. So anywhere from probably 90 to 150 volts would be the operating range. You can go higher. Typical. I think these have somewhere close to 300. So you could go like 270 if you wanted to, but typically somewhere in the envelope of like 90 would be on the low side. Around 120, 175 or something like that would be, where a lot of these vacuum tubes would sit. But I could sit here and I can make a circuit, wire something up. I don't know. I probably wouldn't use the breadboard for the circuitry, because it's high voltage, which I'm not sure what these things are rated for. But yeah, I probably just wouldn't do that. I'd probably design something on a pref board, or you see here I have something hanging. I don't know what I was actually doing with that. But the only other thing you would need here, which, I guess I haven't done or thought about, or maybe I need to wire something up here, but you would need your 6 volt supply or 12 volt supply. I would make it a 6 volt supply so I could wire up different tubes on there most likely, but you would need an external, which I guess I would just use. That's probably why I didn't do it. I could just use this. That would just be just fine. So, but again, this is kind of, a higher level setup for your breadboard, and you can do this to any configuration. Again, this is just set up for audio. So I have XLR jacks. I have an output jack, and then I have all these various potentiometers at different values. So I'm able to, just wire up to a potentiometer, and that was one of the main reasons why I did this, is because I know when I'm prototyping something, I don't necessarily know really what potentiometer is going to work the best at a certain place, or give you a certain kind of feel, or it's a certain kind of transition that you want in your circuit. So the easiest way to do this was to have something that had the potentiometers already mounted. I can switch between them to see which one I really like when I'm using the circuit. And again, you have your input, and output, or your input XLR and your input jack there. So that's basically it. A pretty cool way to do it. Like I said, I haven't made that much with it, but it's very, very useful. So now we'll go over here and I'll talk about what's more of an advanced setup, at least, advanced in my eyes, right? Just because, when I say that, because there's a lot of people on YouTube now. Again, there's tons of people that have electrical content on YouTube, and I definitely recommend go check them out. I follow a lot of people that do electronics online, and I've always noticed that most of the guys on there, they have a lot more equipment than I do. And I have a lot of parts and stuff. I have, lots of parts and components, but I don't really have that much equipment. And they have like old school equipment. And a lot of stuff I've sold, or I've collected some things throughout the years, but just nothing, to the extent of a lot of these other guys. And where I think it's cool, you can go check out some of their gear is vintage. And then, but some people just have like a lot of scopes and, a lot of power supplies or a lot of this and that. And I've never really had the need for it. I mean, the technology today is just so advanced that, I mean, it pales in comparison to even the stuff that I had when I grew up. And when I grew up, I just had a multimeter, and I thought to have an oscilloscope was like amazing, and I wasn't, I was probably like in my 20s until I, actually got an oscilloscope, and this is just a Rigel oscilloscope. I want to say it's 100, no, it's only 50 megahertz for 50 megahertz for channel. And we can talk about an oscilloscope maybe in more depth sometime. But I mean, like I said, look how, and they come slimmer, I think, even today now, so this thing I think is actually behind in technology compared to what you can get now. And there's really, you can find even more affordable ones. But let me give you a whole sweep of this stuff. So we have our function generator, oscilloscope, benchtop multimeter, and you have a 30 volt dual power supply. Okay. Like I said, I call this advanced because to me it's all you need, probably more. No, I'm not gonna say more than you need, but this covers really everything. This is why I've always almost been curious why a lot of people have so much stuff and so many different meters. This will do like, I don't know, I want to say like 90% of everything that need to be done. One of the things I can't get is, so I can't get FFT, so I can't get in like Fourier transforms on here, which is basically like a spectrum analyzer. There is a new scope out that's like, I think it's like just under $500, which is pretty affordable, pretty inexpensive for an oscilloscope, and it's a 4-channel. It's like a basic model. I think it's a Siglet. I think that's what it is. I think it's a Siglet, and it's a 4-channel, and it does transforms. It has a spectrum analyzer, which is like, I mean, you couldn't ask for anything more for audio electronics specifically. What a spectrum analyzer basically does is it gets you to see the whole frequency range, the whole frequency response of that particular item, that you're testing. So it's really useful. And typically, and that's the one thing though, a spectrum analyzer, if you get a spectrum analyzer on its own, they are very, very expensive. They thousands of dollars for a spectrum analyzer. But they've recently started to come out with oscilloscopes that have, a native a spectrum analyzer. And of course, these things aren't going to be as robust as the ones that I'm talking about that cost tens of thousands of dollars and all that kind of thing. But I don't know if you really need one that costs that much. Again, I've just never been in that situation as a builder, as a designer, doing, like I said, mostly audio electronic stuff. I could understand when you're doing like precision stuff in like healthcare or something like that, and why that stuff would be important, like if you're working in a lab. But for people that are just wanting to build some things, prototype some things, make some products, this stuff is more than enough. And you can actually do even less. This is something else I wanted to talk about in regards to beginning electronics. One of the coolest things you can do is make some of the equipment that you're going to have to use later on. So out of all the equipment up here, there's actually 2 pieces of equipment in particular that are like really, really pretty basic to do on your own, that you could either design on your own, or you can get another schematic and kind of, study it enough to where you can feel comfortable building it and do it so you can have something to work with. So the 2 things are the frequency generator and the power supply. Now, your power supply doesn't have to be this big, it doesn't have to be dual channel, and it doesn't have the what's complicated about this might be the current control and maybe the voltage control. That's going to add a lot of circuitry to this, okay, and the displays. But you could get something like a display like this and be done with that. But these controls might be a little bit more complicated. But you could, let's say, if you could just build a a um a power supply doesn't have doesn't is not variable, right? Just like a steady state power supply, right? Like this actually has, it's a dual power supply. It has dual variable, which for these knobs, but this actually has a 5 volt supply here that's fixed, right? So you can just have a, let's say you build like a 5 or 6 volt power supply that's fixed, and maybe you do another one that's 12, and then you have it like in a box like I have here. And then you can do that, and you can hook it up to like a variac, and you can make it as powerful as you want, like I do with that one. See, I just don't have it. This one was designed for high voltage. I could use it for low voltage, but it was designed for high voltage. Um, but I see I don't have another low voltage one because I basically use this. But if I was beginning electronics, that would be something that I would want to think about, and I could make, like I said, make something with a couple different taps. That would be pretty cool too, so that you could control it with a variac, but you could have it to where maybe you had 3 different circuits on there, and they all range in different voltages. So maybe they were, maybe it went from like I said, like 5 to 40 to 100 or something. Who knows what you're going to build that you might need that. Again, if you're wanting to get into vacuum tube stuff, then you're going to need some high voltage. But modern electronics, they're going to be, most of it, if you're going to do things with integrated circuits, is going to be from 0 to 5 volts, right? And then you're going to transistors. Transistors are going to be usually cap out anywhere from 30, from 5 to 30 to about 60. Usually is where transistors are going to cap out around 60. There could be some higher voltage transistors that go to 100. So I'd say build yourself something from 100, from 0 to 100, that has those kind of increments, that has a 5 volt increment, a 30 volt, and a 60 volt, then maybe to a 100 volt increment, or the one that goes from 60 to 100 on one tap, and then one that goes from, I don't know, let's say like from 12 to 30. Okay, that would be cool. And then one that goes, that's around from 0 to 6. So 0 to 6, 12 to 30, and then 60 to 100. That would be a pretty cool idea. That would have a lot of benchtop utility for you. You'd be able to power everything that you ever want to power in electronics with that, for the most part. Now the next thing again would be your function generator. This is surprisingly a very simple circuit to make. A function generator is just a device that just makes signal. Okay, so this is just going to give us different types of waves. I can turn it on here. This is pretty inexpensive, so choose your poison, right? This thing is pretty expensive. It's 2 channels, and this just gets me to throw signal into something when I want to test it. But you have a sine wave, so it has there's frequencies, and then you change the amplitude, and you can offset it, and you can change the duty cycle, you change the phase, and all this. But you have your simple waves. So you have your sine wave, you have your square wave, you have a sawtooth wave, and then I think you have some kind of like arbitrary wave as well. And that's all you wouldn't need the arbitrary wave. That's one that gets a little bit, I think, this is more for technical analysis. If you're going to build one of these, all you really need is a sine wave, a good clean sine wave, and then you have your square wave, and maybe a sawtooth wave, which the circuitry to make something like that is actually not very complicated, and again, infinite benchtop utility, because like I said, this is kind of, when we talked about books and talking about like an evergreen, this is kind of a very much an evergreen product. It's something that just like, you always need it, never goes away, it's never not going to be needed, and it's just it has a high order of utility, and it's a very simple thing too. This is another reason why I said I don't know why people have a lot of different kind of equipment or various things, because like something like this, it should do you, as long as the signal's nice and clean, and you can get a very like a good what do you want to say, this has like good headroom, it can go from, it has a good amplitude factor. I don't know what it is on this one offhand, but we can test it out right now. So it'll go to 15, 20. It goes up to 20 volts. I mean, that's crazy. I mean, that's fine. I think that's 20 volts peak to peak. So it's got a lot of there's a lot of energy it can produce, right? So it can produce a big signal, basically. So you should be able to test anything with that. And yeah, I mean, and of course, again, like I said, just like with the power supply, you know, the buttons and the display are what's going to make it complex. But you don't have to have that, or you could have something else external to it. To replace the buttons, all you would really do, if you made one of these, all you would really do is just have different taps for each different type of wave, right? Then you'd have one tap for your sine wave, another tap for your square wave, and another tap for your sawtooth wave, and you just tap the things. You know, you change. You know, you buy some connectors, and you get your different connectors on there, and then you just use that wave, and then you would just have a potentiometer. You know, you have potentiometers to change your frequency and to change your and your amplitude. Okay, the frequency and the amplitude are going to be the most important settings that are on there most of the time, and you could use a multimeter to count the frequency and to count the amplitude. If you needed two multimeters, or if you could find something like this, an aftermarket circuit that could read the hertz, that could read the frequency, and something that could read, you get an AC meter that could read the to read the signal, and then you're good to go, and you can do it that way. Like I said, look for some aftermarket parts something that might help you. I want to do, again, my time is limited a lot lately, but I definitely want to maybe do an overview video of a frequency generator, so you guys can see that it shouldn't be very intimidating, very much within the realm of someone beginning electronics could do that and could get great utility out of it, especially when I just talked about with the power supply. Building your own would be a really cool thing too. So this video is getting a little long. Oh, another thing I wanted to mention. The power supply circuit. So this is a power supply circuit that I had made a while ago. It's actually for a Raspberry Pi project that I made a long time ago, a couple years ago, in fact. And I just haven't had the time to put it all together. And I recently designed a new board for it. The board that I originally designed was a little bit bigger, but that really wasn't the problem. The issue with the other board that I designed was I didn't have enough space to actually put the heat sinks on there. So I couldn't put the right heat sinks on there. So it would cause the regulators to get too hot. So I could only run the thing for so long before it would overheat. So I designed a new board that would incorporate enough space for the new heat sinks. And this one should work great, but it's a 2 volts. It's a dual power supply board. I want to say it's on here. So one of them is 24 volts. The other one is 5 volts. So basically, it's for an amplifier that runs the Raspberry Pi and has like a media station attached to it. So it's basically you could say it's like a streaming amplifier. You could go on the internet with it and do all kind of things. It's basically made for a streaming amplifier with Raspberry Pi, and the 24 volts, that is what will run the amplifier, and then the 5 volts is what will run. It's a 5 volt input that will run the. Oh, that's a 5 volt output. No, so that's a 5 volt output. So it's a 5 volts that goes to the Raspberry Pi. This is all regulated. So it's 12 volts in, 5 volts out for the Raspberry Pi, and then there's 12 volt or 24 volts in, 24 volts out for the amplifier. But it's all regulated here, and it has some trim pots. There's a trim pot there and a trim pot there. And the deal is with this is I think it even has. If we look close, I don't know if I can get it on camera, but yeah, you can kind of see. You see KR Labs on there. It has KR Labs on there and STEM and stuff. So it's even marked. But the deal with this is that whenever you make circuit boards, you can't just make one. You typically have like maybe anywhere from 5 to 10 that you have to make as a minimum to get them printed. So I have a couple extra of these, and one day I'll do some giveaways, or if you ask me about it, if you have a need for something like this, then after I test them out and make sure everything's all good with them, then I'd be happy to, send them out to some people that might be interested in having them. So, and I'll do more of those things, throughout, our journey in electronics. I think, I guess, as I mentioned earlier, my whole goal with this is to get into STEM education and start doing some STEM educational things here on the farm, and part of that will be designing circuits. And one day I do want to have a whole slew of different circuits to build, that kids can learn electronics with and build their own kits and stuff like that. So that this goes right along with that kind of initiative. So there'll definitely be more to come, and if you have any suggestions. So I couldn't put the right heat sinks on there. So it would cause the regulators to get too hot. So I could only run the thing for so long before it would overheat. So I designed a new board that would incorporate enough space for the new heat sinks. And this one should work great, but it's a 2 volts, it's a dual power supply board. I want to say one of the, it's on here. So one of them is 24 volts. The other one is 5 volts. So basically it's for an amplifier that runs the Raspberry Pi and has like a media station attached to it. So it's basically you could say it's like a streaming amplifier. You could go on the internet with it and do all kind of things. It's basically made for a streaming amplifier with Raspberry Pi. And the 24 volts, that is what will run the amplifier, and then the 5 volts is what will run. It's a 5 volt input that will run the oh, that's a 5 volt output. No, so that's a 5 volt output. So it's a 5 volts that goes to the Raspberry Pi. This is all regulated. So it's 12 volts in, 5 volts out for the Raspberry Pi, and then there's 12 volt or 24 volts in, 24 volts out for the amplifier. But it's all regulated here, and it has some trim pots. There's a trim pot there and a trim pot there. And the deal is with this is like, I think it even has, if we look close, I don't know if I can get it on camera, but yeah, you can kind of see, you see KR Labs on there. It has KR Labs on there and STEM and stuff. So it's even marked. But the deal with this is that whenever you make circuit boards, you can't just make one. You typically have like maybe anywhere from 5 to 10 that you have to make as a minimum to get them printed. So I have a couple extra of these, and one day I'll do some giveaways, or if you ask me about it, if you have a need for something like this, then after I test them out and make sure everything's all good with them, then I'd be happy to send them out to some people that might be interested in having them. So, and I'll do more of those things, throughout, our journey in electronics. I think, I guess, as I mentioned earlier, my whole goal with this is to get into STEM education and start doing some STEM educational things here on the farm, and part of that will be designing circuits. And one day I do want to have a whole slew of different circuits to build, that kids can learn electronics with and build their own kits and stuff like that. So that this goes right along with that kind of initiative. So there'll definitely be more to come. If you have any suggestions on what to build, any kind of design projects, do let me know. Have a good one, guys. Thanks for watching.